Welcome to Developing Graphics Frameworks with Python and OpenGL, Part 9, Triangles, Squares, and Hexagons. In a previous video, you learned how to render a single point in a window using the GPU by hard-coding the coordinates of the point in the shader. In general, geometric figures are defined with many points, which are going to require the use of vertex buffers, where you will store an array of data. In the previous video, you learned how to upload data to the GPU using some OpenGL functions that you created an attribute class with to automate this process. In this video, you're going to learn how to use that class in an application to draw something more interesting than a point. In particular, we're going to try to draw triangles, squares, and hexagons. All right. But before we begin, there was a typo in the last video that I'd like to correct with you first. So last time, you learned about the attribute class, and we wrote all this code last time. However, in this class, we had written at the very bottom when we were uploading the data, we had mistakenly written GL Vertex Attrib point, but the correct command is actually GL Vertex Attrib pointer. So, if you've been following along with these videos, you'll need to make this change before we proceed. Go to the attribute file, look in the attribute class, and under the method associate variable, you'll need to make sure that each one of these function calls actually reads GL Vertex Attrib pointer. All right, I'm sorry about that. But that being said, let's go ahead and learn about how to use the attribute class. All right, now all these associations we're going to set up, we need to manage this data somehow. Right? Remember, we've got two different things happening. We have data, which is stored in vertex buffers. We have an array of data. And we have variables in a vertex shader. And last time we learned about how to create associations between those two objects. However, we need a way to store these associations. And this is done by something called a vertex array object. You manage data involving attributes, and you can manage many sets of associations for different geometric figures. And to do that, you bind and unbind these objects as they're needed. So we'll learn how to use those. There's really two functions we need to know in OpenGL. And it's very similar to the functions we used in creating vertex buffer objects, except these are the vertex array object versions. The first, we have to find some available references or available names for vertex array objects, and we can create those with a function glGenVertexArrays. The parameter VAO count is how many references we need. We'll typically only use one at a time. And once we've created that, we always have to remember to bind it. Right? That basically makes the vertex array object active, and that'll allow us to store associations or later on to recall those associations into memory by binding it. And only one vertex array object can be bound at a time. So if you bind a second object, that also has the side effect of unbinding the previous. All right, with those two functions, we're ready to start writing some code. And so let's go ahead, going back to Sublime Text or your development environment of choice. This video is part 9, so in the core directory, I'm going to create a new file and save that right away. I'll call it test-09.py. All right, first thing we need to do is import all these useful classes we've written before. So we'll start with from core.base, import base. Right, our application will extend the base class. And make sure it doesn't autocorrect to lowercase. Right, the name of our files is lowercase. The name of our classes begins with an uppercase letter. We'll also use from core.OpenGLUtils, import OpenGLUtils. And then that class we just wrote, from core.attribute, we're going to import the attribute class. And finally, we need the bindings from PyOpenGL. From OpenGL.gl, let's import everything. All right. So first, let's just try rendering 6 points. And they're going to be in a hexagon style arrangement. And so we'll need to create a buffer for that. So I'm going to create a class called test, extending the base class as always. And as you may recall, in the base class, there are two functions which we need to implement. The first is initialize. And in this class, I always like to start off by print, initializing the program. And then let's write our shader code. Right, so let's start off with a multi-line string, VS code for Vertex Shader code. It's a multi-line string, so I'm using triple quotes. And in this case, we're getting some data, some kind of incoming or inflowing data from a buffer. So we're going to create a variable with a type qualifier in vec3 position. And that is declared before the body of the function. All right. As you may remember, the goal of any vertex shader, the one thing you have to do is assign a value for the final position. So let's say GL position, it's a vec4. And in this case, again, instead of hard coding it, I'm going to take the x, y, and z coordinates from that variable. And again, for some technical mathematical reasons, which we'll explain in a future video, positions are represented with a 4-dimensional vector, and the last component's always 1. And don't forget your semicolons. All right, and that's it for the vertex shader. All right, we've defined a position, so we can go ahead and use some triple quotes to close that. And next, let's write our fragment shader code. Again, a multi-line string with triple quotes. In this case, I'm just going to code in a color. So let's maybe say void main. And I'll do something a little bit different. Let's do gl underscore frag color equals vec4. And maybe I'll go for like a cyanish color this time. So 0.0, 1.0, 1.0, 1.0. And that'll color the pixels corresponding to the shape cyan. Once we've got the two shaders, we need to go ahead and compile them and get a reference to the program object. We'll need that later on, so we store it in a self variable. Program ref, we'll get that from OpenGLUtils.initialize program. All right, we have to pass as parameters VS code and FS code, right, for the vertex shader and fragment shader. All right. Once that's done, it's time to start writing the rest of the code for the application. We can set up some render settings. Again, my first time through, I'm going to go ahead and render these as points. So I'll set a nice large point size so it's easy to see. And now comes the new code, right? So we talked really briefly just a few minutes ago about setting up a vertex array object using OpenGL functions. I'm going to implement that now. It only happens once in the initialization. And so we'll set up VAOs, which are, again, vertex array objects. Let's see, for this, again, I need to do two things as always. Let's get a reference. I'll call this VAO ref. GL gen vertex arrays. I only need one reference. And then I need to bind it to activate it. Then I'll bind the vertex array. I'm not storing it in a self variable because I'm only using one. I'll kind of set it and then let it be. All right. Next, we need to set up the Vertex Attribute. And so we get to use that class we created. So set up Vertex Attribute. All right, I'll call this position data. Basically, it's just going to be an array of vectors. It's really a list of lists in Python. So I'll start off with 0.8, 0.0, 0.0. The z coordinates are always going to be 0. Let's see, 0.4. I always like to line these up too. 0.4, 0.6, 0.0, negative 0.4, 0.6, 0.0. So these are going around the origin counterclockwise. Negative 0.8, 0.0, 0.0, negative 0.4, negative 0.6, 0.0, and 0.4, negative 0.6, 0.0. I'm going to go ahead and line these up, just because I like to line things up. All right, and those are the 6 points which are going to define the hexagon. Okay, now I'm going to go ahead and create an attribute, and I'll call it position attribute. It will be a new attribute object. And I initialize these with 2 things. First, a string representing the name of the type of data, and then just the data itself. Now, let's see, I need to go ahead and set up the association. And remember, we do that with our function. We recently wrote associate variable. Right? And to what variable will I be associating it? I need to give it a reference to the program, and then a string containing the name of the variable. And this will return an integer, which is how I can reference that variable. If for some reason I'm not actually using that variable, or maybe I made a mistake and spelled it wrong, then it would return the value -1. All right, that's all we really need. We've got the attribute set up. All the initialization tasks are done. The next task is to implement the update function. All right. And so again, what do we need to do? We've already bound the VAO. I need to tell OpenGL which program is being used. Right, so GL use program self.programRef. And then I'm going to draw those points. Draw arrays, GL underscore points. I need to tell it how many points are going to be drawn, 0 and 6. Now, in general, I'm not a fan of hard coding numbers in there. Right? If you were to add an extra point to this list, but if you were to accidentally leave this number right here, this is the number of points being rendered, it wouldn't render all your data. So sometimes I'll be, admittedly, a little bit pedantic, and I'll define another variable called Vertex Count, and I'll have it automatically calculate the amount of data, so the length of that list, and I might just use self.vertex count up here. I think it makes the program a little bit more readable. All right, that sounds pretty good. Let's go ahead and save, and if there's no typos, in theory we should see 6 points on the screen rendered in the style of a hexagon. Let's go to, after saving, Tools, Build, see how that looks. All right, what's happening here? No module named core. Oh, do you know what I think I did? Did I? Yes, I saved this in the wrong directory. This is an important thing. It's good I made this mistake in case this happens to you. The reason it can't find the module named core is I accidentally put this in the core directory. So really I need to move this to a different folder. And so I'm going to go ahead and open the containing folder. And I'm going to take this file, I'm going to remove it from this directory and put it back in the base directory with all my other applications. Whew. All right, I was worried about that for a second. Let's go ahead and, oh, I don't want to save this one. I can delete that one. It's this test I want to run, located in the correct directory. So core is in the correct relative position. Let's try that again. Tools build. Right, hello from the Pygame community. Oh, one more thing I need to do. I'm so excited to see these points. I forgot the last step. We defined the class. Now we need to create an instance of a class and run it. So create instance and run. So down here at the very end of the application, I'm going to say test run. All right. Let's go ahead one more time. Third time is the charm, as they say. And look at that. We've got our 6 points arranged in the style of a hexagon. Fantastic. So this is our first example of creating a program which uses attributes and loads data into a buffer. Now, since we have more than one point, we can also do a few interesting things, which I want to show you now before we proceed. For example, you might not want to render just points. Most graphics involve lines and shapes. So we can change this really quickly just by changing a few lines of code in our program. I'm going to go ahead and close this for a moment. Right, and I'm going to change in the draw arrays, I'm going to change the draw mode. There's lots of options available. For instance, if you want it to look like a real hexagon, I can use a mode called GL line loop, and that will connect each dot to the next dot. Now, by default, lines are only 1 pixel thick, so I might want to change that render setting as well. And I'll do it just once, back up in the initialize function. So if I scroll up a bit, in addition to setting point size, I can also set the width of lines with the OpenGL function GL line width. And so I'll make those pretty thick. I'll make them 8 pixels wide. Right, and with these two changes, setting the width of the line, as well as changing the render style, right, you'll see all the points connected. You should see an outlined blue hexagon. Pretty cool. And there's actually lots of modes to draw lines. Right, instead of line loop, right, that'll create kind of a continuous path between your points. I could also just use the mode GL lines, and that creates a sequence of line segments. Right, so if I were to run this program now, right, it'll connect vertex 0 to vertex 1, then skip over to vertex 2, connect to vertex 3, then skip over to vertex 4, connect to vertex 5. So it'll group them in disjoint pairs in case you're looking for a segmented look. Similarly to drawing lines, you could draw triangles. There's a mode called GL triangles, which is worth checking out. So if I save and give this a run, it groups the vertices in sets of 3. So right, in this case, vertex 0, 1, and 2 form a triangle. Vertexes 3, 4, and 5 are grouped into a triangle. And so this requires a multiple of 3 triangles to render correctly. So that's another mode. However, you might want a filled-in hexagon, and so there's a mode for that as well. So let's go back to the code, and one more draw mode to try out. This is called GL Triangle Fan. I'll go ahead and run this and show you how it looks. All right, so what's interesting here, it looks like a filled-in hexagon, but this is really and truly 4 triangles that are being rendered. Triangle Fan uses the first vertex, which is right here, as its base point, and then it'll connect vertex 0, 1, and 2 to form a triangle, then vertex 0, 2, and 3 to form a triangle, 0, 3, and 4, and 0, 4, and 5. So there's really 4 adjacent triangles in this case. And if it was rendered as kind of outlines of triangles, it would appear kind of like a folded extendable fan. And so that's another draw mode which might be useful to you. Now it's also possible to draw more than one shape to have multiple vertex array objects. So we have a little bit of time left. I also like to create a second application where we do the same thing but basically doing it twice. So I'm going to go ahead and this time I'm going to carefully create a file in my base directory, not the core directory. And I'll call this one test-09-b.py. And so it'll be recognized as a Python file. And it turns out I can copy a lot of the code from the previous example. Right? A lot of this is almost like standard template code that we will eventually factor into some framework classes. But for now, I'm back in test09. I'm going to select and highlight all of the import statements, the definition of the class, and really most of the initialize function. right, all the way down to the render settings. I can easily reuse all of this code. So I'm going to go ahead and copy that code, head to my new file, and paste that all in. Right, so again, we're reusing most of the code. So in this case, I will change the comment though, because we're no longer rendering a hexagon. We're going to render a triangle and a square. Cool. Now to do this, we just have to do the same things we did before, but really do them twice. We're going to create data for a triangle and also data for a square. So we're going to need two vertex array objects, each of which is going to manage a different attribute for us, and then we'll switch back and forth. We'll bind and unbind the vertex array objects when we get to the update loop. Right, so first, I'm going to set up a triangle. First, by generating a VAO for the triangle. So I'll call this VAO try. This will be GL gen vertex arrays. We just need one. Then we need to bind it. And again, I'm giving it a class variable with self because I will need to reference it in the update function later. Position data try. And so I'm just going to go ahead and enter 3 vertices for a triangle. Here's the first, negative 0.5, 0.8, 0.0. Next, negative 0.2, 0.0, 0.0. And last, negative 0.8, 0.2, 0.0. So this will create a triangle in the top left quadrant. Next, I need to put this data into an attribute. So I'll call this position attribute try for the triangle. That's a new attribute storing vec3 data. Let me scroll this up so you can see it. Vec3 data. I'm going to give it the information from position data try. Cool. Next, I need to set up my variable association. That'll be stored in the vertex array object that's currently bound. So position attribute try, associate variable. Again, I always need to give it the name of the program, or the reference of the program, and also the name of the variable that it should store data in, which is called position. Excellent. All right, last thing I'm going to do, self.vertex count try equals 3, because triangle has 3 vertices. Or, just to keep the same pattern going, the number of vertices are the length of the data array. So position attribute try, not attribute, position data try. Cool. All right, that's all we need to do for that. We're going to do the same thing, but for a square this time. All right, so same set of code. We're going to set up a square. And we're setting things up. Same set of code. VAO square. Let's call it VAO SQ. GL gen vertex arrays, just generating one. Next, I'll bind the array. I need to create a list of position data. In this case, let's see, I've got it written down over here, 0.8, 0.8, 0.0 for the first vertex. This will go in the top right corner of the screen. 0.8, 0.2, 0.0. Next is 0.2, 0.2, 0.0. Last vertex, 0.2, 0.8, 0.0. Cool. We've got the data. Let's go ahead and create an attribute. Position attribute square is a new attribute. And as I'm typing this out, I'm noticing a typo up here. I used 3 T's for attribute. Let's see. This is taking a vec3, position data square. Then I need to associate this to a variable in the program. And again, it's associated to the variable with a name of position. Right, let me go ahead and scroll up so you can see that. And same code as before. And again, let's store the length. Self.vertex count square is equal to the length of position data square. Excellent. We've got our two vertex array objects set up. All right, let's go on down and create an update function next. Def update self. Right, in both cases, we're going to use the same program. Self.programRef. Right, what is going to be different is binding and unbinding each one of these vertex arrays. Right, if I tried to draw vertex arrays right now, I would just get the square because it was the last thing bound. But in this case, well, I want to bind both of them. I'll draw them in this order. GL bind vertex array, self.VAO try. And then once it's bound, I then activate the GL draw arrays command. Let's use GL line loop. Now starting at 0 and vertex count try, which we know is 3. And next I'm going to do the other binding. So GL bind vertex array. All right, once we've rendered that, go ahead and switch to the square data. GL draw arrays, GL line loop, starting at index 0, self.vertex count square. Whew. So that's the update function. Right, same thing, but we're doing it twice, and this is an example of how to manage multiple sets of data. Now if we go ahead and give this program a run, right, if everything works, we should see both a triangle and a square. But we need to instantiate and run the program. Run the program. Really, I get so excited and I just want to see those figures on the screen. I leave out an important step. Oh, okay. Something else is not good here. Test object has no variable var sq. Oh, VAO. Spelling. It'll get you every time. Again, third time's the charm. Let's go ahead and run this. Yes, and there we go. We've got two different buffers, both using the same program. And so this illustrates both binding and unbinding and kind of switching between those. So this is a hint as to how things are going to go in the future when you want to draw multiple shapes. We'll need to manage a bunch of vertex array objects. But if you got to this point, congratulations. You now can draw multiple shapes. And in the next video, we're going to make these shapes multicolored by using yet another buffer. So we're going to learn how to pass color data into the fragment shader next time. So thanks for watching.